Now this program is to print prime numbers between 1 to 100. Earlier we did the prime number program for one number. See, the logic is from here the same. See, factors count equal to 0, I in range 1 to n plus 1, etc. But earlier there was n equal to int input, like that there was a sentence. But now the sentence is changed. That is, this is for one prime number and this logic is given in the big for loop. Therefore this program is doing, this logic is doing for a range of numbers. Very simple nested loop setting. Earlier I was doing for one prime number by asking n is equal to input. Of course the same logic, everything. Here I am giving print, not print. Okay, the logic is same. But now I have embedded this in a big loop. Therefore this process is done for several numbers. My numbers are ranging from 1 to 100. Okay, see now how it functions. Now this program is prime numbers from 1 to 100. What are the prime numbers it prints? Only prime numbers it prints. Say 1 is not prime number, 2 prime number, 3 prime number, 5 prime number. It has to print. I do up to 5. See, what is n now? My n is 1 because range starts from 1. What is I am doing 1 I. Okay, I am taking 1 R, I am taking 1 FC, right? FC is 0, of course, that is factors count, right? For I in range, whatever the number, if you want to know that whether it is prime number or not, that number has to be divided from 1 onwards till that number. My number is now 1. Therefore I in range 1 to 1 to, it is 1 plus 1 2. 2 in the sense 1 to 1. That means only 1 will come. See, 1 to 10 means it is giving 1 to 9. 1 to 11 means it is giving 1 to 10. That means 1 to 2 means it gives 1. One time it repeats. Now I value is 1. R is equal to n% 1. n% 1, that is 0. Is it 0? Yes. Factors count is 1, of course. Going back. But range is over because your range is only up to 1. It comes out. Say, this part is the body of this inner for loop. This everything is the body of this for loop. Therefore after crossing this loop, control comes here. What is FC by the time? 1. Is it 2? No, nothing is done. I want only prime numbers, not prime numbers. I don't want required. Okay, so leave it. Then control goes back. My number is now 2. N value becomes 2, right? FC is 0. Factors count, because when number changes, the factors count should be changed. For I in range 1 to 2. See, 1 to 2 it takes. That means I1, I2. For 2 numbers it takes. R equal to n% I. 2% 1. It is 0. Is it 0? Yes. FC equal to FC plus 1. 1 factor. Then I value is now 2. Right? I value is now 2. Because it is 1 to 3. Range 1 to 3 means 1 to 2 gives. So and 2% is 2 now. What is 2% is 2? 0. Is it 0? Yes. Factor count is equal to 2. Then I crosses comes out. What is FC by the time? It is 2. Therefore it prints n. What is the n now? Number 2 prints. It is my prime number, first prime number between 1 to 100. Then control goes back. Then what is n value now? 3. What is FC value? 0. Right? Again, for I in range 1 comma 3 plus 1, 1 comma 4. 1 comma 4 means it gives 1 comma 3, 1 to 3. Okay, 3 times it repeats. Then 3, my value is 1. 3% 1, it is 0. Is it 0? Yes. Fc equal to Fc plus 1, it is 1. Going back, I value 2. Yes. 3% 2, it is 1. Is it 0? No. Going back, what is I? 3. Yes, within range. 3% 3, it is 0. Is it 0? Yes. Factors count is 2. Going back, out of range. Coming here. What is Fc by time? 2. Since it is 2, it is printing n. My n is 3. 3 also prime number. It has got printed. Then going back. Now n is 4. Like that it checks 5, 6, like that. Up to 100 numbers. This is possible because a loop is given within another loop. A loop is given within another loop. Then only this is possible. This n is giving 1 by 1 numbers. The inner loop is deciding whether they are prime or not. This n is giving 1 by 1 numbers. The inner loop is giving whether, inner loop is deciding whether the number is prime or not. Okay.